Alright, this is the solution of the previous activity where you need to make the servo sweep from the Raspberry Pi, and then you're gonna change the speed when you press on the push button on the Arduino. And so, well, once again, let's start with the Arduino side. So I'm first going to do the button pressed code, and actually let's open the previous activity, which was 5. So I am not going to write the complete code for the push button because we just did it in the activity and in one of the previous lessons. So, well, if you want more explanation, please go back in a previous video to get the explanations of that. I'm just going to here copy the code that we already wrote before, okay? So that doesn't come from nowhere, that comes from something we have already done. Okay, and I'm going to also initialize the serial, as always. And then, well, you see that's the part of the code I want to copy here because we're not gonna write that again. Okay, and that's it. I'm gonna close that. So in our code for now, we have the define for the button, some variables. We initialize the button and the previous state. And then in the void loop, so make sure you have the correct blocks of code here. So well, in the void loop, we read the current time, we check the duration since the last time the button has changed. If this is greater than the debounce delay, then we read the push button, we compare it, we update the variables, and if it's high, the button has been pressed, and we send button pressed. So just to be sure, let's upload that to the Arduino activity 6. Down uploading, let's open the serial monitor. I press on the push button, button pressed. If I press multiple times, okay, great. Now let's do the code for the servo. So I am going to initialize the servo, so define servo pin 12. Let's include the servo.h library. And let's create, so we can create it before that or after, it doesn't matter. Servo semicolon. And here let's do servo.attach servo pin. Okay, the servo is initialized, and now in the void loop, after we have read, or before, it doesn't matter again. So after we have read from the push button, let's do if serial dot available greater than 0, and then let's check what command we're gonna receive. Let's do string cmd is equal to read string until \n, and then if command dot. So what do we want to receive? We want to receive the servo command with a number. So let's say that we're gonna receive something that starts with servo colon like this, and then the angle we want. And so we can do command dot remove. Okay, we start at 0, 1, 2, 3, 4, 5, 6. So 0, 6. We are left with the number, so int angle is equal to cmd.toInt. What we could do also now, I'm not going to do it, but what we could do as an improvement is to check that the angle is actually between 0 and 180. Okay, so that we don't receive values that are negative, for example, or values that are greater than 180. And then we do servo.right angle, and that's pretty much it. We have the code to send the button pressed message, and we have the code to receive and execute the servo command. Okay, let's check. Yes, I'm going to upload the code and test this code. And well, actually it's better if I do serial.read string until, because this is part of the serial library, not just a random function like this. Let's upload. Uploading. Down uploading. Let's open the serial monitor and let's see what we have on the circuit. So first, well, if you have, like me, if you have disconnected the servo pin here on pin 12, put it back, okay? Because if not, that's not gonna work. So if I press on the push button, still working, button pressed, and then I'm gonna do servo, for example, 0, and let's press enter. Okay, it goes to 0. And then servo with 153, for example, it goes to 153. That's correctly working. So I'm gonna close that, and well, I think we are done with the Arduino code. Let's now switch to the Raspberry Pi code. So you could see that on the Arduino, well, we didn't have many things to do, okay? We just send something here, we just receive something here. There is no link between the two actions, okay? The link between the two actions is gonna be on the Python side. So let's remove all of that. Okay, we know what to do. Let's start from a blank page. Well, a blank page now because I'm gonna use, of course, the structure. So let's go to any of the previous activity and let's just paste the structure, remove what we don't need, like this. Okay, that's the structure to import stuff, initialize serial communication, and then our own kind of void loop. I'm gonna put here 0.01, okay? So we can run this loop at 1000 Hertz. And now, well, let's do the servo sweep first. So we're gonna start here, I'm gonna put last time servo move, for example, is equal to time.time, and we have the time already imported. And then let's say servo delay is equal to, so we're gonna put the different delays after. I'm gonna start with 0.05, or let's do actually this, which is 10 milliseconds. Now in our while true after the time.sleep, so I usually put this at the beginning, okay? Because if you put this at the end of your program and then you have something that is quite big, then you might miss it or you might put a wrong indentation. So that's why I usually put that first, okay, as a best practice, so I don't remove it by mistake or I don't put indentation by mistake. I don't do any mistake. So any code I write after this time.sleep. And so now I do time now is equal to time.time, which is the current time in second, if time.now minus the last time servo move, if this is greater than the servo delay. So you can see this is really similar to what we did here, for example, with the push button, okay? Time now minus last time is greater than the delay. That's the exact same code, but with Python. So we do last time servo move is equal to time now, and then we can do the action. So what is the action? We're gonna start from somewhere, okay? So let's say servo angle is equal to 90. Let's start at 90, okay, which is at the middle. And we're gonna do servo going up is equal to true. So we start at 90 and we go until 180 first. And so what we do is, so if servo going up, then we do servo angle +1, and then else, so if the servo is not going up, which means it's going down, servo angle -1. And so here the angle was 90, we put true here, so we go here, the servo angle is gonna be 91. Now we also need to check, of course, when we reach the max. So if servo angle is equal to 180, in that case, we're going to do servo going up is equal to false. So that the next time, what we do, the next time is we don't go here, the next time we go here, and then, so the servo angle will be 180, but we do -1. So 179 and then 178, etc. And then we also need to check here if servo angle is equal to 0, then we don't go lower and we do servo going up is equal to true. So the next time we don't go inside this block of code, we go inside this one and we start from 0, 1, 2, 3, 4, 5, etc. until we reach 180, and then we go back here until we reach 0, we go back here, etc., etc. Okay, and now that we have the servo angles, so let's keep the indentation we are in that if. I'm gonna do command is equal to servo, like this, plus servo angle, but as a string, plus \n. Okay, so we make sure that we have the same command as here, servo colon and then a number, okay, and \n for the read string until \n. Okay, it seems good. So we just need now to send the command. So ser.write command.encode UTF-8. Okay, so we have the delay mechanism with that if, okay, and the time now, and we have the sweep mechanism where we change the angle here and then we send the command. So here we're gonna send the command every 10 milliseconds. Okay, let's save this as activity6.py. Let's first try this actually, okay? So I am gonna run the script, okay, the servo is connected, and well, you can see the servo is sweeping. Great, it's working. So here I'm just gonna disconnect that for now, so it doesn't make noise. And well, let's continue with the following part of the code. So Control C here. So you can see here we already have a sweep command from the Raspberry Pi to the Arduino, and we do the sweep here instead of in the Arduino. Now I'm gonna add a list. So let's add a list here. Let's do servo delays is equal to, and so we had 0.005 and 0.01. So that's all the delays in milliseconds. So 15 and 20. Let's go with that. And let's say that the servo delay, well, actually, let's put that before. The servo delay is servo delays 0. So the first one. Okay, so we start. Here we don't start at 10 milliseconds, we start at 5, okay? And now, well, in order to change that, I'm gonna read from the serial. So we have this first block of code. So let's put a comment here. Sweep servo. We can put some spaces to make it more readable. And then let's do change servo speed. So the order here doesn't matter. You could do that before or do that before, because we're gonna go very fast in this loop. And so what we do, if ser.in waiting greater than 0, then we do messages is equal to ser.readline.decode UTF-8.rstrip. We check if message is equal to button pressed. So let's use that directly. Then what we simply need to do is to do a change here on the servo delay. And so we need to keep an index actually. So let's do servo delay index is equal to 0. Let's put that here. Okay, and we're gonna increment this. So we're gonna do servo delay index plus 1, and of course we need to check if servo delay index is greater or equal. So just equal should be enough, but let's just use that as a more general condition, to the length of the servo delays. So basically here we are at 0. We do +1, we are at 1. +1 we are at 2. +1 we are at 3. And +1 we are at index 4 that doesn't exist. Okay, the length of the list here is 4. Okay, with the indexes 0, 1, 2, 3, 4. Well, actually 0, 1, 2, and 3. If we reach number 4, which corresponds to the length of the list, then we are out of the list and we're gonna get an error. So we check that. If we arrive at the length, we simply do servo delay index is equal to 0. We come back to 0. And now we are sure that we have a correct index, and we simply do servo delay is equal to servo delays with the servo delay index. And so when we receive the button priced, we are simply going to change this value here with the next value on the list, and this is used where this is used here on this action. So we are going to change the speed of the action basically. Okay, let's try that. So I am going to, so the Arduino code doesn't change. I'm going to run this again. So the servo is sweeping. You can see a little bit faster now. Every 5 milliseconds I press on the push button, it's going slower. I press on the push button again, it's going slower. Now every 15 milliseconds I press again, it's going slower every 20 milliseconds. And I'm gonna press and it's going to come back to the first element, which is 5 milliseconds. So 5, 10, 15, and 20, and 5 again. All right, so I'm gonna disconnect this just so it doesn't make any noise. And the code is working, so I'm gonna press Ctrl+C. So here I didn't put any log on the Python side. You could put some logs here when you actually change the delay, okay, to make sure that you have the correct delay. Adding some logs here may be too much, okay, if you print a log every 5 milliseconds to show the angle. You may do that for debugging, but then, well, maybe that's too much for a normal use of the application. But here, for the change of the delay, why not? Okay, and that's the end of this activity. So here you can see that basically a code that you could do on the Arduino, which is so the application to make the servo sweep, you can do that also from the Raspberry Pi. Okay, so you can choose basically where you control the logic of different parts of your application. So actually here I did the sweep on the Raspberry Pi with Python as a good practice exercise, but maybe the best option, well, it depends on your application, but maybe the best option would be to do the sweep on the Arduino. So to handle this on the Arduino, and then just send from the Raspberry Pi the delay that you want to use, okay? And the application will be exactly the same, okay? The result will be the same, but the code to sweep the servo would be on the Arduino, okay? So here you can see we are in the example where we could do this here on Python or this on C++. And so sometimes it's not necessarily super clear where you should put which code. And well, you're gonna simply learn more about that when you practice with this course, and also after this course, when you practice more and you do more projects, you're gonna have a better idea of what to put on your Raspberry Pi, what to put on the Arduino. All right, and that's the end of this section on the Arduino functionalities. Now we are going to go to the Raspberry Pi functionalities and continue to explore the different things we can do with Raspberry Pi and Arduino. And after that, we are going to start the final project of the course.